three drawings here from the same building. There's the basement, first floor and second floor. I've already set up the basement and the second floor, so we don't have to use time on it, waste time on simple matters, but I will still show you how to get started with MagiCAD for AutoCAD. So what I have here is just an external reference, an architectural model, 3D model there, set up in the background, so I can use the spaces in order to get my designs right. Of course, I've saved the drawing as well. And now, how do we include MagiCAD into the process of our designs? We browse onto, in this case, MagiCAD HP&V tab, and on the left we can see this project button. Click on that one, and what it does is that opens up a select project dialog. First, we want to add this drawing to the model drawing list as it is a model drawing. Then, well, there's two options: select an existing project or create a new project. Of course, as I said, I've already created a project for the second floor and the basement floor, so I will be including that into my project file. It's now called hpvdemo.epj. Click OK, and what we get after that is the actual project management tool. First, let's check the model drawings list. We can see the three drawings that we have here: HPV floor 1, which is the one I have on the background, floor 2, and floor 0. Other things in here: project information, of course, can be changed, project settings, story definitions, how to handle different stories in here, how to get those drawings linked together. Our current HPV floor 1 is now connected to this story 1, which is defined here. Of course, I've set so that HPV floor 0 is connected to story 0 and floor 2 to story 2. Then let's see ducts and pipes. Let's just quickly browse through them. Under ducts and pipes, both have these systems. Under pipes, they are under the specific discipline, but still different kinds of settings for the systems, user codes, names, what type of system it is it included in the bill of materials, different variables can be changed, line types, colors, calculations, what kind of calculations we can do on this system, what sizing method are we choosing for it, and then the different balancing options for this specific system. And also there's the initial sound. If we don't have an actual air handling unit at the end of the line, we only have an open end. This will tell us the initial sound source there. Then the different parts which we've selected for the project. Of course, the list can be changed. If I take outdoor devices, for example, right click on the list, choose select products to project, and I will now be connecting to the cloud, where we have all the latest MagiCAD products available to you in this specific category, which is outdoor devices in this case. We could just choose something from there, let's say weather protection grill. You can see the information for the different sizes, check the diagrams, check the properties, but eventually if we're happy with this product, we just select it to the project, and OD1, let's call it something like that. We can add other information, product variables, object ID formats, all sorts of things to these symbols as well. Now that I click OK, it opens up the product browser once again. If I don't want to add anything more, there it is, OD1 is added to the project. Same thing if I want to get rid of something from the available products. I can just right click and select delete, edit, of course, changes the values in there, and properties opens up the product properties dialog. Well, let's just remove that. We don't need it now. Different kinds of parts, all the fittings are in there as well for bends, T-branches, which are selected for the project. Then there are layer definitions, insulation series, absorption material series, flange series, the different duct series and pipe series, of course, on the pipe side, sizing methods, different units which we will be using in the project, a few additions there. Dimension text, of course, for these products as well. For pipes, pretty much the same thing, systems, layers, sizing methods, and so on and so on. Not that special there. Same kind of logic in there as well. Sewers as well, systems, parts, layers, insulation series, and so on and so on. A few general options on the layers, dimension texts, line types, which will be used on the project, dimension text, properties there shown, text for free text, if you want to add just text in there. Then there's the provision for voids, because we have a tool that you can make void provisions with. Here are the definitions on how they are made, different rules, different owner information, and so on and so on. Variable names, just so for products, of course, we have the P1 to P15, different kind of variables. We could change these names. Property 1. Now, instead of using P1 as the value shown in the user interface and reports, will be showing property 1. Shown on the list, and of course, clicking on default changes it back to P1. Nice addition, gives you a lot of freedom and flexibility. Connection node defaults. What we have is called connection nodes to connect the drawings together. We can have these flow node arrows there if wanted. You'll be seeing those in action in a while. And the last thing here, variable sets. We have object ID formats. You can set all sorts of object IDs using the different parameters set in your project and for the products. Status information, different kinds of how they are used, what's the layer variable, are the locked size, added to the bill of materials, and then running index, different groups, different formats, so you can add a running index from specific numbering for different products. Well, now, as you already saw, model drawings list, all three are now connected, so our project is ready for us to begin the actual designs. Let's close that. Let's start off with ventilation. I'll be making a few examples here, show you the basics of ventilation design on MagiCAD for AutoCAD. You'll probably get a clear insight on what can be done. So we'll be starting from these 8 offices here. Let's start off by installing an air device. Say we already know what the airflow should be in that room. We want 30 liters per second of air in that space. I think we could use that one. Let's see, properties for this size. Yes, 30 liters per second would be good. Yeah, no need to go any bigger. That's good enough. So size is then selected as well. You could set a symbol for it if we wanted. No need to do it. The actual product here can be seen. We can have dimension text in there as well, showing the different parameters with it. Then color length could be changed if we want to. You can see that changes, but I'll keep it at 40 millimeters. Good. Then click OK. There it is. The product is in the middle of my cursor. So you can see that the open end or the connection of the air device is facing the left side of the screen. So how do I change the orientation of it? Of course, I can always right click, choose direction here, which will give me the possibility to freely rotate it. Or also a possibility, if you take a look at the bottom of the screen here, we have these no connect direction, grill direction options, quick rotate. I could choose the direction here as well. Or maybe if I just want to use my keyboard instead, there is always a capital letter, which if I tap on that one on my keyboard and accept it with space, there it is. It's oriented to the right direction. Let's put it in the right direction. There we have it. Yeah, just about in the middle of the room. So now that I've clicked it into the room, into the right place, now what I have to do is add all the information for the system and the height level. So what systems am I using? Supply 1, it's coming from the project management only. Since I'm installing a supply device, that was the only supply system which I've defined in there. Then different status, not defined, existing, original, and so on and so on. I'm going to keep it as not defined, so we can actually have all the results with bill of materials. It won't be locked or anything. We could set a description for it as well, typing free text if you want to. No need to do that still. Then the different height levels. As you can see, there are 3 different editable height levels here: top level, connection level, installation level, and also bottom level there, but that's not available for us to edit. And you can see that that's the same exact value as on installation level. So I know that my ceiling height is 2.4 meters, so let's change the installation level to that value, 2.4. Now, as you saw, all the 3 values changed, or the 2 which I didn't edit are updated according to the value which is set there. So if I set it to 0, you can see these change as well. Let's keep it at 2.4. Just going to make sure, yeah, I'm using current floor coordinate system. Then, now that I click OK, it's installed into the project. There it is inside the room. Easy peasy. I could have just kept on going, install these to the rest of the rooms as well, but I want to show you a couple of tricks that you can do and save time by copying different things. Let's then draw a duct here. A few options on how to get started with this is that you can always start the duct drawing command from up here, which opens up the MagiCAD HPV design options dialog. I'll shut that for now. Also, an option is to select the air terminal if you have such in here, and there's this plus grip on the open end of it. Click on that one. Same applies here. The same design options are opened. So First, what we'll do is select a duct series. Let's go with the generic circular duct. Size 100. I think that's the connection size. So let's use that one. We won't be locking the size, and then routing is set to smart. I'll show the rest of the dialog in just a second. It's not all there, but that's the simple way. What's good about this is that it is a floating dialog, which means that we can keep it open and change the sizes as we go along. So if I just draw it here, now for some reason if I want to change the size here, I can just go along. Of course, size isn't the only thing that we can change. If we now expand the dialog, we get a lot of more information on what can be changed. Installation series, let's say I want to put fire protection in there for just a second. There's a short segment there with that one. You can change the different fitting types, flange series, choose alignments on what, according to what point we are drawing this, height difference in branch, all sorts of things. And of course, we can change status information as well if we need to. Yeah, I'm just checking different things here. So there's now an awful design. It's Monday. I've had a rough weekend, and I just noticed that no, this is not good. No, not good at all. So I've ended the command. What do I do then? You can always just change. Start the duct command again. Connect to that open end, and again start drawing. So what happens if I want to get rid of all of these things? Can always try and go back. Let's take that away for a while. I can draw it, but if I try to go past this segment, it's not possible while using the mouse, of course. So how do I get back to that point? And I want to redo my designs here. Again, behind the right mouse click, there is a few of the quick options shown here as well. There's this back option, which takes you back to the last segment, which was started there. And also clicking down here or using the keyboard, this can be done. There we are, back in that spot where we want it to be. Make sure, yeah, not defined, yeah, nothing, that's good enough. I'll just roughly draw that one there. Let's also draw a branch there. That's good enough. And yeah, let's do a similar network on the other side of the office as well. When we have these plus grips here, plus would be add duct or a branch. In this case, there's the move part also, and then there's the create similar. I'll create a similar duct segment there. No, good. So as I clicked on an empty space, there was nothing there that I could grip to. It again gives me the install product dialog here. I have to select the systems, the height levels, and I want to make sure that I'm using the same height levels as for the other side as well. So I have this reference button here, click on it, select that one. Now I'm using the exact same height levels as on the other side. Let's draw it there. Nice. Good enough, good enough. Then, as I said, we could install all the devices one at a time, or we can just, if they're the same size offices, they have the same airflow in there, we can just use a copy tool. Instead of using just AutoCAD copy functions, we've added our own tool here, which is called a branch copy, which means that now that I started, first it asks us for a root node. Root node meaning what is, from which point do we want to copy from. I'll show that fitting there, and then the show pipe or duct here from this point to what direction we want to copy from. This part, okay. Then just let's, there we go. And as I copy these to the other rooms as well, I'll show it here. You can see that it makes an automatic connection there. So there's no extra open ends. Everything is connected there. Now, once again, I want to copy this branch to the other side as well. What do I do then? Again, direction or quick rotate. I'll just use quick rotate. Turn to the other side. There. Good enough. Looks like computer's a bit slower now, probably because I'm doing the recording here using the graphics card there. Good. So now we are now connected to the main branches with the devices. Looks pretty nice now. Let's add a few devices as well. Make the risers to the other floor and so on and so on. Let's start with adding a few chilled beams into these corner offices. Let's say they're meeting rooms. Let's see. Properties, ventilation. Yeah, let's use that one. 20 liters. 20 liters per second for ventilation. So again, for this product, we for chilled beams, first we need to select systems for it. Let's say 20 liters per second. Let's put two in each meeting rooms. Then the cooling systems and heating as well. Got quickly check what kind of there's no heating information here still. That's interesting. 0.04 maybe. 800 maybe. Yeah, seems better. Let's put that to 2.5 then. No matter, we're not going to do any heating calculation on it, so I just want to show you how they work with ventilation products in here. Good. There we have it. And now I think the connection's on the other side, so let's 2.4 on this one as well. Yes, got it on the right side. And 2 in there as well. There we go. So now a few more products in there as well. Of course, we need to connect these to the network as well. Let's see if I edit that one a bit. Let's put that one as well a bit that way. There we go. And as I said before, let's add a connection here as well. Let's put a plug in into that end. Same thing here. Good. So then I'll start the duct command again. Let's connect to that chilled beam there. So it gave us a conflict here. As you can see, the active duct which we are using is a circular duct with the size 100, as it says there. But the selected part that we are trying to connect to is a connection size 125. So what do we want to do? Do we want to change active settings, or do we want to keep active settings? I want to change the active settings, though I'm actually using the 125 connection here. Okay, let's confirm that. And now let's see the height difference in branch. I'm pretty sure that these the duct which I'm drawing here is not on the same level as this one. So now that I'm using height difference in branch as a smart option, it will use the biggest possible angle to connect to the main duct here. Of course, I do have the possibility of locking the height difference to a specific angle. Let's see what will be the angle here. If we select that one, 15-degree angles. And repeat duct, same thing there. Probably the same in here as well. There we go. So now those are now connected to the network. Let's give that some extra space. I'll just move that one that way. Oh yeah. Oh, well yeah. In there, on that side, I installed a plug into that end of the duct, so we'll be getting rid of open ends. Also a possibility, if you know that you don't need this straight part here, you can just select it and delete it. There it is. Not needed anymore. It's gone forever. Then the next step, well, I already know this, but I'm still need to explain it in the sense that you will understand what I'm doing here. My air terminals here, they have a built-in flow damper, which means that they have this damper position value in there, but there's no damper built into these chilled beams, so I need to install some sort of adjustment component before these, so the airflow will be somehow controlled. So what I'll do is that I'll install a flow damper here. So there's fire dampers, flow dampers, silencers, other duct components, but my interest is now on the flow dampers. And I think if we check iris, yeah, there we have a lot of different sizes. We can use that one then. As you can see, the size is not locked here. So I'm just going to select the product symbol that is used as a default option here. Click OK. Oh, there it is. Again, mysteriously froze for a second. So flow damper, select connection part. I'll have to show where it's actually installed onto that duct, as well, and these two here. So it's automatically sized to that branch size using the 125 here, which is our connection size for the duct. Then a few more options before we go any further. Let's install a rectangular duct into that air duct shaft there. There we have duct, rectangular duct, maybe say 600 by 300. Let's see what size it is then. Just put it there. Supply. I'll start from butterfingers again. I'll start from 2 meters. Okay. Then now that I want to draw upwards in my drawing, how do I do that? Once again, right clicking is an easy option, and there's this Z, because that's the coordinate axle there. Z, where do I want to draw it? I'll draw it to 3.5 meters. That should be my story height in this project, or in this story at least. I'm using a 90-degree angle. There we go. Show direction. Now went the right way. There we have. Now I have if we check all the 3D there, you can see there it is on that level. And as I said before, we can, with MagiCAD for AutoCAD, we can connect drawings together so that we have connections between the two. We can perform calculations on multiple drawings at once. How do we do it? We create a connection node here, so we can import that into the second floor drawing and then use it there. So again, right click, connection node, ID number looks like it's giving first available number there, description, let's call it supply on AC shaft. Destination drawing, there's some intelligence behind this. Surprise, surprise. So destination drawing, it's detecting that we are going upward. There's a whole lot of different possibilities in here on how to connect the different upwards and downwards, of course, the most commonly used. What symbol are we using? Let's keep it as it is. Maybe let's keep it reset like that. Then, now that everything's done, we can click OK. Let's put it. There. Finally caught up to that. Yeah. So now it's showing me I'm going upwards. Still gonna do a thing here. So there's still the open end on the 2 meter level that I said there. Where I started from, there's an open end. So now that I click to draw a duct there, it gives me 2 options. There's the duct, there's the open end where I can connect to. Let's click OK to that open end, and let's just put a plug in there. There. And now we still have to connect these 2 sides, that side and that side, to that duct, so we have a consistent system there, everything connected together. Let's once again start draw duct. Now again I have selected rectangular duct size 600 by 300. Let's click on that one. Oh, that's interesting. Well, let's go with circular 100 there. I was expecting a conflict there, but looks like they've changed the logic there. Yes, branches there. That's the one I want to change. I want to the branches. I want to have these instead of having a T-piece there. I just want to have some sort of colors there connected from a rectangular to a circular duct. Yeah, connection height looks good. There we go. And the same thing here. Let's use the create similar option. Yes, still using. And now let's zoom in. Good. So now we are now connected with the with the colors there to the rectangular duct, which is now good. Let's remove those extra parts. There's nothing to be connected to that network anymore. Everything seems pretty good. So let's go on to the second floor. So as I said, there's nothing here at the moment. I'll make as you can see, it's pretty similar to the first floor, the layout of this second floor. What I'll do is that I'll just updating project cache. There we go. I'll just copy everything we've actually done here. Copy with the base point being 0.0.0. 130 parts there. And let's paste everything to the second floor using the same insertion point 0.0.0, and that is where we are now. Good. So of course we saved some time here with this, and I'll also remove that one from there. I'm just gonna make some space here so you can actually now see what happened. So on the first floor we created the connection node, which was set at the top of that duct there on height level 3.5. So I go to the second floor, and now I want to get that connection node appear in my second floor. Under tools we find this connect node option. I'm just going to bring all system groups. There should be only one system group in there which is being used, and that's the ductwork system groups. I'm selecting an area inside which area I want to have that or where it should be the connection node, and I want to bring connection nodes from floor 1 drawing. Okay, then as I selected the area option, I'm just going to make sure that it's inside that AC shaft. There it is. Connection arrow downwards, and as you can see now that I twisted the 3D, there it is at the bottom there. And when I select that one, center part on height level 0, 0, that's of course On this floor, it's on height level 0. So let's draw from that one. We can normally start drawing from this one. Active duct was circular 100, selected part was 600 by 300. Of course, we're going to change it. And now, again, let's just use the Z option, draw it up to 3.5, where we will now have the open end. Then let's make sure we connect these two together, change the fitting type there, and to 575. And once again, I'm just going to make sure that it remembers that one. That's interesting. Let's check that again. Oh, that's why. Yeah, so it broke the duct for some odd reason there. Delete that one for now. Let's maybe take it back a little bit. Good. Yeah, it was using the outlets that break the duct as T branches. That's not what I want to do. I just want to the same options on the first and second floor. Yeah, now they are connected. So looks like we've almost done our first and second floor. I just want to make sure that we are doing something correct here. As you can see, one of the air devices is set in the staircase. Of course, we don't want to have it there. Let's remove that one, modify the network a bit. Now, yeah, looks a lot better. Looks a lot better. And now the next thing we want to do is perform sizing on this. Or maybe let's start with the summation, because if I select that part from the duct, we can see that there's no flow in that part just yet. So let's do summation. I'll do it by system, supply 1. Yeah, external connection nodes. Let's calculate values and let's save calculate data into drawings connected with connection nodes. And let's see the calculation report as well. Okay, there it is, the calculation report showing the entire network part by part, showing the flows, showing the velocities, showing all the sizes there, what is actually happening in there. These can be copied to a clipboard, printed out directly. You can see product properties through here, the reports showing this route only from the starting point to the actual device there. Let's update the information. Okay, update to model. See one of the parts there. Now flow shown there. Velocity 16.6 meters per second. That's a bit overkill. So let's do the sizing. Once again, let's go by system, supply 1. External connection nodes will be calculated. Won't be using the last value. Then options, a few changes here on the new version. Let's see if I can explain all of these. Select objects to be sized. You do have the option of selecting just specific objects in the project. Again, saving calculated data to the floor 1 as well, since it's connected, showing the calculation reports, and we have the possibility of locking all the sizes after calculation. If it's done, and then that could be an option. Sizing method, it's already defined in the system through the project management, but we do have the possibility of changing it here. I'm going to use what's defined in the system. And then rectangular duct options, maximum widths, maximum heights, and minimum width height ratio. override sizing method settings can be set as well for rectangular ducts. Let's click OK. Again, it does all the calculations on the supply network, of course, showing the size of the rectangular duct has changed to 800 by 250. Previously it was 600 by 300, sorry. Showing the flow, showing the velocity. Everything should be according to the rules. Looks like there's position conflict. Let's see. Update to model, mark all. Oh, there's a position conflict there. It's probably on the, yeah. So let's make a few modifications in here. We can get rid of the problems there. There's not enough space. Not enough space, so let's do it like this. Plug to the end of that one. Just a minor problem here. We'll give us some more space there. So let's try the sizing one more time. Warnings, no, nothing. Update all these to the model. And now, as you can see, the sizes have changed. This, which was previously 100, is now 315. Looks like that's inside the wall, so that should be moved or change size there if needed, but that's for another day. Then still a few options. As you can see, the air terminals, for example, don't have any pressure values, no damper positions, no nothing there. Let's run balancing as well. Again, on the system, let's add this show index run, which means that we will show the defining device in the system for the balancing values. There we have getting all the adjustment values, pressure values through this. Let's see, warnings, no, nothing. Update to model. Oh, there was one. Of course, it's the index run. Let's see, mark all. It's on the first floor. That one was the defining device in the system. Good. No worries. That was there for a reason. So there it is. Now, if we check the information here, we now have the pressure values, the damper positions, still missing sound values, so let's do that. Sound calculation of chords. Interesting. Mode examination. So I did balancing already. Update model. There it is. Oh, there. I don't know. Something odd happened there. Well, now, as the initial sound source was 60 decibels, we now get the levels for the air devices as well. A bit high maybe, so maybe we should install a few silencers eventually, but this way you can get all the information here. There it is. So 36, 37, and so on and so on. So that is of course a problem there. Let's clean those away. Now there it is. Our ventilation network is now done. We've managed to do everything necessary there. About 40 minutes ago still. Good. We have time to do heating a heating network, and also let's hope that we get some time for actual domestic water calculations and network as well. Maybe even sewers. So let's start from Yeah, I'll start with the first floor. Let's clean those away as well. Just to make this a bit quicker, I'm going to be using the same drawing here to create the heating network, so we don't waste time creating another drawing. Let's start again by installing devices. Let's go with radiators, heating radiators or water radiators, both an option here. See, that has a lot of sizes. That as well. Yep, I'm going to be using the bigger one, C22. I think Purmo, yeah. Purmo as our radiator. So that is our radiator type, which we will be using. And select the system for it, heating, H1. Then required heating power, 750 watts maybe. Room temperature, yeah, 20 centigrades. Connection size, no, I'd use the 10 mil there. So, of course, now we can see the actual calculated data for this size, height 300, length 400. That would produce us 222 watts, which is 30% from the required heating power. We could just change these values and check whether, which is good, which is not. But that would take us some time, and we might want to see all the possible sizes available to us in a single selection. So let's use this select size option. Sizing data, what is required of this? Minimum height 200. Okay, I'm more interested on the maximum height. I don't want more than 900 mil height batteries. Minimum length 500. Yeah, again, maximum length, that could be an issue, so let's put 1.2 meters there as the maximum length. Yeah, from 90% to 110%, that should be about what we require of the radiator. And now if I calculate, well, yeah, let's say 95 to 1105. Calculate a bit, yeah, make the list a bit smaller. Height, well, let's use that 500 by 900, which is giving us 101% of the required 750, which is then 758. Okay, size is then updated there, and the product is updated there. Now we have the possibility of changing the connections there where we wanted to. We could get a mirror image of it. I'll use the original one first. Here to select it. Let's go products. See, no. Yeah, I'll use that one. RV2 as our radiator valve. Then drawing options. Let's draw a valve. We could also set draw field radiators. I'm not going to use that one. A bit lighter for the graphics card. Then click OK. There we have it inside the space. Yeah, the height levels are good enough in the beginning already. Let's put a few of these in here, one in each room, of course. And I'm lining them with using the snap option here, so that the sensor levels are aligned. Let's check options. I'm using the same radiator, but with the mirror image, as I want it on the other side, and let's turn it that way. Yeah, high levels are good. I think that might have slipped Yeah, it slipped a bit. I can always change that one later on. And there we go. Yeah, that was not aligned, so let's move it 25 mils. Now it should be. And now it's aligned. Good. Good enough for me. Yeah, I'm just I'll copy those to the other floor as well. There we have them. Oh, looks like those need to be moved a bit. And of course that should be then deleted. Different sized rooms there. Good. Then back to the first floor. Now I want to draw some pipes for the heating network. Start the pipe drawing command, and again, first we need to let's diminish that for a while. Supply return pipes. What kind of pipes are we using? Steel pipes, synchronized, of course. If it's not synchronized, we could use different pipe series if we want it, but there's no reason to do that. I'm going to use the size 10 because eventually we'll be doing the sizing and getting the right size pipes. Pipe positioning, 100 millimeters between the two pipes. Good. Routing is smart. Height difference, let's put 45 and minus 100. When we do a branch, that will be the option there. Let's start from somewhere there. Heating one, let's put this on 2.7 meters. Good enough. And same thing here, 2.7. There we go. So what I'll do now is that I'll unload that for a while, so you can now see what happens when we do our magic here. So let's start the pipe drawing command, and as said, the height difference is with a 45-degree angle. We do a branch with a 45-degree angle, and the branch should be 100 millimeters lower than the main pipes there. Let's make sure that I'm online with it. Of course I didn't check. Let's make sure that I'm should have probably changed the order of the pipes, because now I'm gonna do that before we continue. I'm just gonna move that to the other side. There we go. Good. I just want to make sure that we avoid any extra collisions there. I've drawn that there. It's on 2.6. It should be on 2.6. And now I want to connect to the fourth radiator. 1, 2, 3, 4. And I'm going to show the radiator there. I want to connect to that one. So how does it do the connections? First, it finds the right alignment there, drops down to floor level, goes beneath the radiators, and automatically connects to those. Then let's continue with this one, just connecting from the radiators to the main pipes. Good enough. Same thing here. I'll do it one more time from this point. Yes, making sure that these using the same options there for the order of the pipes, so it can be set through here on which side is which pipe. And again, let's connect to that one and see what it looks like. Good, connected, nice and dandy. A few more times. There we go. Let's turn the architectural model back on, reload. The colors went a bit funny. Well, no matter, we can still, once we reload, that should be all good. Yeah, pipe alignment looks good on both branches. Yes, excellent. Now to the branches one more time. I think now we should be using that option, if I remember this correctly. Yeah, my logic works. Rarely does, but now I got lucky. There we go. And then just attaching the remaining radiators there. That one. And the last one on this floor. So there it is. First floor is now nearly done. So what we want to do is have a similar setting on the second floor as well, and then eventually connect these two together. I'm just going to quickly do this here. Let's going to make sure that the pipes are in the right order. Maybe easier if I do it like this. I have to think about it. Yeah, because I need to get them aligned on the second floor as well. So what I'll do now is do the connection nodes first. So I can always use the Z function and then create a connection node at the end of that pipe. But there's also the possibility of creating what's called a riser. Works especially well with radiator networks or with domestic water if there's more than just one pipe or duct there, because you only have to do these once. On the first floor, so I started the riser where I'm drawing the top level 3.5, bottom level at 0. Destination is upward and downward. ID numbers should be the same because I might want to copy these in the future to other floors. No need to add anything else there. There it is. The connection nodes nicely made there. Let's do it on the other side as well. Return pipe. There we go. Riser, yes, same thing, upwards and downwards, ID numbers 2 for these. There's PV floor 2, and now let's get the connection node in here. Again, same system groups from floor 1. I'll just select the area. Should be somewhere there, and there it is. Same thing on the other side. Oh, nearly missed it with the area selection. Still, hooray! Let's start drawing pipes from these. Draw it up to 2.7. 1, 2, 3, 4. And now let's make sure -100, 45-degree angle. Pipe order should be fine there. Just gonna make sure that it actually is what it should be. Yes, great. Remaining radiator still connected. And for this one as well, and there we go. Let's draw the other side to the correct level. 2.7. 1, 2, 3. There's only that should be good enough. Let's see. Just on that side. Good. Great, no extra collisions there. And the last branch then, there we have it. And one more time. Now, good. So, first and second floor are now connected to each other. Nearly everything's done there. Let's remove those extra ends. Yeah, no open ends there. None on the first floor as well. And now I already created the connection nodes on the first floor, which are going down to the basement. Let's go get these connect nodes. Instead of selecting an area, let's just get them automatically. There they are. Good. Draw the pipes from them down to, looks like that's 3 meters. Good. Let's save some time here. Draw them on the same level as well. And just connect them. I know they're now collisions, but we still just want to connect those, and let's do the calculations for these as well. Again, starting from flow summation, let's go to heating, cooling, special systems. System was heating 1, calculating flow, showing all the calculated data, saving it there. No errors there. Oh, Now I know why. First floor, I had these are unconnected, so if I don't want to calculate those, let's do with the branch option. Showing the pipes there, I'm not calculating those shield beams at all. Sizing, same thing. Branch, same options as in ventilation. No need to worry about those. There we have no warnings there. Size change, we use size 10, now it's up to 25 there, the biggest size. Not a lot of changes there, but it is a small network, of course. And still the balancing as well. There we have warnings. No, not a single warning. Showing the adjustment values for the radiator valves. Showing the flows, all the pressure values as well. Both on supply and return. What's nice about this is that if I choose one of the radiators, show this route only, it will first show the supply line and then the return line for that specific. If let's select one of the radiator valves product properties, we can see the dew point in there on the diagram as well, where it sits nicely. Okay, updates model. There we are. About 50 minutes ago, I think if I'm quick, I'll be able to show you those domestic water and sewer example here. I'm just going to use the second floor. Let's that one. Oh, something happening with the architectural model, probably caused again by the graphics card. Needs to fix that one up later on today. So water and sewer points. Let's start installing a few of them. Let's start with the toilets. Yeah, there's a toilet. Connection size 110 for the sewer point, and we need a freshwater connection for this if we want to actually flush the toilet. We've used these as two separate products, so we can actually manage the calculations separately. But there it is. This define the distance between water points. 125. Let's put that 25 on the side. Okay. Let's see. There's only the connection points are now shown. Let's change that afterwards. Tap water, sewer, height levels look pretty good to me. So there are only these 2 points here. What happens if we want to see the actual product in here? I can always go to HPNV viewport preferences, and since it's on the pipe side, I'll go to 2D and use 3D geometry for valves, components, water and sewer points. Click OK. There we have the actual product itself. Let's install similar, again butterfingers, similar setup on the other toilet as well. Okay, that's the reason I had a Q in there. Wouldn't work. Yes, height levels are good. Now, yes, perfect. Of course, if there's a toilet in there, we probably need some sort of tap and a wash basin as well. Both of these should be in there. Distance between water points, it's the connections 150 millimeters apart. Let's put that on 125. Looks like a Mickey Mouse now. That's my rule for myself, that I make it look like a Mickey Mouse, and then I can change the distances afterwards. That's usually a good point for water and sewer points, especially for taps and basins. There we have it. Yeah, I guess I can see that the tap itself is not in the right place where it should be. Good enough there. Yes, 1.2. Let's change that to 1 meters. Great. I'm just gonna move that one 25 millimeters that way, so it now looks a bit better. Great. There it is. A few setups. How do we use these? How do we connect with them? Let's, of course, first draw the pipes. Let's go with cold, hot, and circulation water pipes. I only have cold and hot here, so I'll use those. This right there, next to the wall. I want to go on top of that ventilation pipe. Let's make sure that we are not colliding. Let's have 50 millimeters tolerance there. And I want to go on top of that one, 2.7. Let's go to 2.8. Okay. I'm just roughly going to make these here again. And then fix the connections afterwards. So once again, we need to make the connections from the pipes to the actual products there. Choose the pipes there. Use these as these first. Looks like size 18. Good. First we want to go down. We are defining the cold water pipe there. I'll put it on 150. And make sure that there's 100 millimeters between the two pipes there. And let's see the height level from that one. That's 2.8, so let's put it on 2.7. There. Yes. Good. Nicely done there. Same for this one. But now that should be 50, since that's going to be the lower pipe once we turn this way. And it will be there, the corner, Z 2.7, yes. And it will give us a confirmation that we are using different size pipes there. Let's remove those extra ends, and yeah, we still have the toilet there. Now let's do a cold water connection there. Maybe drop it down again to 50. And then let's just center level to that one. We don't need to make any branch changes there or anything. So for this toilet, I mean, for the other one, of course, we need to make the changes. 50 mil. 2.7 for this one, just to avoid the collision. There we go. Now two of the toilets are now connected to each other. Calculations, sizing, pretty much the same thing there. Let's run through them. Of course, it is a small network, so let's see what happens with balancing. I may have to change some of the options there for the balancing. Maybe I'll run this as system since there's nothing else on this system. Good. Then sizing, yes, everything looks good. Not much changes, a few there, of course. Size 18 now as the main pipe size there. And let's run balancing again. This is where I'm expecting to get errors. Yeah, flow 192, update to model. It will tell us mark all. That's way too high. Why is that? Is that in the project? I'll show this one here. Water systems, the tap water system calculations option. The balancing lowest service pressure is set to 275 kilopascals, and of course there's only 4 things in that network, so the service pressure is actually pretty high for that. And if the high limit is set to 180 there, let's see if I change it to 200 and run balancing again, I don't get any errors. It's 190 and 192 as the flow value, so it gets a lot more than it should, but we're still able to do the calculations. It will give us the results, but eventually when if we would have more time, I would have made a bigger one and have an example that actually resembles an actual network there. Then last thing, I'll just show sewer pipes in here. Just select the toilet there. Let's go with a sewer pipe PVM 110. Let's use full, put it to 6, routing as in smart, drawing downwards, yes. And there we have it. If I choose a Z option here, let's draw it down to -500. There we are. Now, of course, I have to connect this one as well. Same options there for the fall. Set this. There we have the connection there as well. The calculation options that we have for sewer is only flow calculation, so of course didn't select that one. There we go. We can see what the flow is, and the sizes are then just 110 locked. Part outside of flow routes. Okay, yeah, it's those water basins there. Don't have to worry about them. The information is still saved to these. We can still use those.